About dynamic cloud. Dynamic cloud is an integration point between the enterprise application and cloud native application. The cloud native application in our case is going to be on IBM BlueMix. For the integration, we are going to leverage the IBM SoftLayer message queuing service. So let's see how exactly all these work together. First, before we delve into the details, let's take a quick look at the message basics. So there is a message and there is a message consumer. The message producer sends across the messages. Now, there could be more than one message that the message producer could send, which is more than what the message consumer can consume. So what typically happens is the messages are queued in an intermediary space. We will talk about more the relation between these producers and consumers. So what are the elements to keep in mind? One, the average number of messages that could be in such a queue. Two, the average waiting time in the queue. These are important considerations. In addition, of course, there are certain other considerations like how to process the incoming messages. Do you want to use first come first service or some priority or some randomness? Not only that, whether you want to even allow the message producer to send across messages if the queue is full or something, there are different tactics that you can play within it. Now, what we will do is let's see what happens if there are more than one producer. Of course, if there's more than one producer, it doesn't matter, the queue is going to fill up. What happens when there's more than one consumer? Let's take a quick look. If there is just one consumer, one producer, it's a very straightforward thing, or even more, it's all queued up in the way that they are received, and the consumption happens. Now, when there are more than one consumer, what happens is it goes in a round robin fashion. So first it goes to consumer 1, then the consumer 2, then it waits till the consumer 1 or consumer 2 are available for further processing. Then the message goes in a round robin fashion or any other priority order that we decide. So this can be very useful, especially in terms of handling breakdowns in the consumer and also, say, overcoming network related issues between the queue and consumers. Could have it possibly in different geos and different kind of, again, tactics you can adopt in consumption also. Now let's understand how this simple queue becomes a very big help as part of the bigger picture. So what we're going to talk is, here there's a producer in a typical model where the consumer is available, he just exchanges the message. But as we just saw in the message queue, there's an intermediary space where the queue exists. So the producer sends the message to the queue, the consumer gets the message from the queue. Okay, what does this help us? The number one thing is there is a space decoupling. There is no need for the producer to know who are all the consumers before, and vice versa. The consumers don't have to know the producers. The next important thing is producers and consumers don't have to exist at the same time. Okay, let's delve into the details of what this means. So data persistence via the message queue is a critical component. Okay, if both the sender and the receiver, or the producer and the consumer, are active, then there is no problem. We could just go ahead and send it to the queue and consumer is available. Sender sends, then receiver is not there. The consumer does not exist or is not alive right now. Doesn't matter, the queue is going to hold it for us. Now what happens if the sender doesn't exist or the producer doesn't exist? Here the consumer is active, he can process what is still pending in the queue, and if he wants to become a sender to put the response back into the queue, fine, great, or take some action. So that's what he can do. But when the consumers are still having something in the queue, there is still work getting done. Now, what about a scenario where both the producer and the consumer both are, dead or passive? So essentially, we have the elements still lying in the queue, safe and dandy. So this is an important thing where the time decoupling brings in value, and that value comes from the data persistence in the message queue itself. Okay, let's look at a sample scenario. In a sample scenario, John is one of the many investor advisors in a bank. He and other advisors assist customers who walk in or call in. They have a desktop tool and they do all the things. Now, part of the functionality, the advisors believe should be made available to the customers. There's no point in making them call in this era and trying to go through different permutation combination, what is good for them, and play with the numbers and tell them back or send an email or whatever. So the bank decides, okay, we got a enterprise application that can't suddenly scale up to all its customers because they are queued by emails or the process of call itself one after another, and depending on the priority and urgency, this advisory action takes place. Now they want to open up. Okay, how they can make it happen? For a larger audience, especially they want to open up to the guys who have the mobile and the tablets, um, you know. So let's say they want to integrate the authentication. They don't want to ship out the secure information out somewhere to the cloud. They also want to ensure that they don't ship all the data of the customers outside their enterprise. They want to ensure only the minimal information that is needed for the session is sent as needed. And okay, leaves just for the duration of the session ideally, so on and so forth. Of course, in the future, they want to leverage the cloud-based analytics that we can use the real-time data. So how they move from the enterprise app and integrate with the cloud native app and so on. So there exists their current application, which is desktop based. We'll look into the exact tiering and the model and in typical enterprise application model in a bit. But right now, what we're talking is, can we make the existing application cloud enabled? So we'll talk in a minute what exactly it means. What we also need to do is stand up a initial version of a native app on BlueMix, so on the cloud. So what this allows essentially is we need to be able to talk to the IBM software message queue service. So this is where the message is produced and saved. The incoming requests are put there, and what is going to happen is the cloud enabled version of the existing app consumes these messages. Of course, in the future, they can move to, say, a better native app that can be having everything else on the cloud, maybe, and so on and so forth, or maybe not. This is good enough. So let's understand the tiering a little bit better. So here you have the enterprise users, some kind of interface, maybe a desktop application, maybe a web browser interface, doesn't matter. Then there is a logic which is depicted as a view. which is the service. Then there is of course some data repositories, LDAP, and other data that exist probably in ERP, maybe some database, doesn't matter. Now, this is the typical layout. What we're going to try to do is we're going to first have the potential users come via say mobile phones and tablets hit a application over HTTP. Now, what this does, most likely HTTP, into the BlueMix application. What this does is, okay, they got to the application which needs to now translate this to a message form. Why? Because just simply there is no way for the enterprise app to be able to service these potential users simultaneously. So what we're going to do is set up a queue, push them into the queue. Here you see how the decoupling queue, just like what we saw in the previous chart, comes into play. Here the enterprise application goes, fetches the queue information, gets it back in, processes it, and responds back, possibly with other message in another queue, or takes just some action on the database, or sends an email within the enterprise. Any kind of action that is appropriate. So let's proceed further. So what does a typical messaging look like? So here is the mobile app sending some authentication information initially, like how we mentioned. The BlueMix application sends this, it's a standing web service, it sends it basically to the soft layer message queue, and the enterprise application goes and does a enterprise internal authentication on this ID and then generates a response. If it's successful, of course, then goes forward to the next stage. Otherwise, it won't. So that is where the application logic and the interpretation of the message themselves would make sense. So the next stage is very similar, except that here the data is being used. What is being mentioned here is that every message that comes back could have some additional transaction key that can help ensure that this is the right person who is aware, because there's only one entity that can take the key. There is no way that the message can be read by two people, so the key is known only to the one. And if the application is the only one that is aware of the key, only he can send it back to confirm, and of course, while coming back, he receives a different key. So this kind of a chaining can keep going on, or similar such, concept. So let's spend a minute understanding the soft layer HTTP-based queue service. So this is a very inexpensive service. First 100,000 messages are free per month, and the cost is so low it approximately works out to be $1 for 1 million messages. Now, what are the language bindings? The enterprise could have a C Sharp, .NET based environment. You could have Java based environment. Of course, the binding from BlueMix at this stage has to be one among this. Right now, there are a few supported, but Java is the most preferred on the BlueMix platform itself at this time via the Liberty profile. But any one of these are perfectly legitimate interfaces from both the producer and the consumer side. It could be very different, as we mentioned in the past. Now, the transaction itself happens on with the queue via HTTP. That's why it's a brilliant service offering that you should take advantage of. Whether you're using or not, it doesn't cost you at all anything, most likely, for experimentation with 100,000 messages per month at the threshold. Now, what are the benefits of this approach? Location transparency. Doesn't matter where you're setting up. Today you have in your data center, tomorrow you want to move to a cloud hosted platform, your enterprise logic, or whatever it is, it's transparent to the location both for producers and consumers. This is phenomenal. Next thing is the firewall NAT traversing. So this is a big issue. You don't have to open up any particular port other than being able to reach from within the organization to the outside world. So nobody is going to reach out from the outside world into the corporate or enterprise environment. This is a big thing. Just like how you configure browsers to access to the outside world, same way you just allow the enterprise process to be able to reach out to the queue, filter what messages are genuine, ensure throw away that which are spurious or unknown origin, and things like that. Ensure you work with the right kind of you know messages that are consumable. So of course, scale out of the handler. So here, let's say the BlueMix app itself is scalable. Let's say more members come in. We saw in the last presentation about auto scaling on BlueMix how this scales beautifully. There's no problem. Also, it's scalable on the consumers. So if your application can take care of the interaction with the databases, etc., simultaneously, you could stand up multiple instances of your consumer. There's no problem. So each one will pick, each one will look exactly same. You can stand up if there's a lot of queue. Otherwise, shut one instance down. It's all up to you. Different permutation combination possible here also. You can increase the memory, etc. So this whole thing is resilient design based on a resilient service, essentially. And the biggest advantage we see here is there is no new infrastructure needed to set all this up. Just you click, sign up, you host, everything is great. Uh, that's kind of advantage we have this existing offering. So let's take a quick look at the demo itself now. Demo here. What we are trying to accomplish here is we have already done a couple of steps. First thing is we got an enterprise Java app, we got a mobile app, we already sent the BlueMix app up and hosted it at a specific BlueMix URL. So this mobile app is going to communicate with this BlueMix app, and the BlueMix app is going to put into the invisible queue, which we're going to pick it up in the enterprise app and do the respective processing. So what I'm going to do today is I'm going to do enterprise authentication from an app here into IBM, enterprise. So this is my intranet ID, and I'm going to ask a question to internally running Watson. I'm going to ask a question, which is the longest river, and submit a response. So we see a response coming back stating, okay, there's some message, it's not very great. The message has been put into the queue. Now what is going on is the producer has sent the message to the queue, but I'm going to start the consumer right now. So the consumer is now starting here. It's waiting for any messages. So it should pick up the initial message. It is saying it is being queued. Actually, there's an internal queue into the Watson itself, so which we are looking for. In the meanwhile, it sent an acknowledgement telling that the enterprise authentication succeeded, and basically, which is the longest river, is what is the information that I sought. So now Nile is the answer that came back. Now I'm going to ask, what is the capital of Portugal? And I'm going to submit a request. So this time again, I want to talk a little bit about the authentication itself. So you see in the background the messages are being processed. So we're going to try to recover any messages that are put on the queue for us. So we see here, what is the capital of Portugal? That is the question that was acknowledged. Now what is the answer for that? It turns out to be Lisbon, which is the right answer. Now what I'm going to do is just, it is a temporary password for the purposes of demo. I'm going to stop this and just, I'm going to change this to something else, which will not, of course, work. And now I'm going to ask a slightly different question. Of course, I have ensured that the application does not stop me from answering just because I entered a wrong password, but let's watch what really happens here as the first step. So, which is the largest waterfalls? Sorry. Sending in. I'm looking for any responses back yet. Still, I've put a 10-second, you know, simple Java app, just polling anything arrived. There are different tactics we will talk about in the next presentation, hopefully, about the complexities involved there in setting up different kind of ways these queues, topics, and all other concepts. Right now, what we can say is basically we got the authentication failed. That's what I wanted to show. Okay, but the request is received. As I mentioned, still the request is continuing to be processed. And this is most likely in Asia somewhere, and this is the response that we got back. So thanks for watching how we can leverage a very in a simple way we can integrate the cloud native apps and the enterprise apps without much problem using the queue. So here we're getting the message from the queue. Here we are looking at certain other attributes and looking whether the attributes are useful in enterprise authentication. And then we are processing the message further, asking internal Watson the question that came in and posting the response message back. Okay, that's all for today. Thank you.